This presentation is going to be on energy. The first two quarters you learn chemical science, so the third and fourth quarters you're going to be learning about physical science, beginning with energy. So what exactly is energy? Energy is the ability to do work. And a little bit later we're going to talk about what doing work really is. Right now, I want you to know that energy is the ability to produce a change in itself or surroundings. Work is done when a force causes an object to move in the direction of that force. And there can be many different types of forces. For example, look at this picture. The baseball player does work on his bat by exerting a force on it. The bat does work on the ball, and the ball moves in the direction of that force. So energy is transferred from the bat to the ball. So energy is everywhere around you. It's constantly moving from one form of energy to another form. So work is a transfer of energy. Work and energy are expressed in units of joules. Just like we had units meter, liter, gram, you now need to learn that work and energy use joules. So 1 joule equals 1 kilogram meter squared divided by S squared. And the way I remember that work and energy are in the units of joules is I think I go to work and use up a lot of energy, so I go to the store and buy joules. So like I said, energy is everywhere around you, transferring from one form to another constantly. So we use energy to do work. It lights our cities, it powers our vehicles, the trains, the planes, the rockets. Energy warms our homes, cooks our food, plays our music, gives us pictures on the television. Energy powers machinery in factories and tractors on a farm. Everywhere you look around you, you can see energy everywhere taking place and moving from one type of energy to another. Energy from the sun gives us light during the day, keeps us warm. It dries our clothes. It helps plants grow because that radiant energy from the sun comes down and is absorbed by the chlorophyll in the chloroplast. And photosynthesis takes place, turning carbon dioxide and water. That radiant energy turns into chemical energy when that chemical reaction takes place, and it creates glucose and oxygen. So that glucose is the stored chemical energy stored in that plant. And then along comes animals and they eat those plants and they get that stored energy. Then along may come a predator who might eat that prey, and then that gives them more energy. So food is a chemical energy. Okay, so again, energy is defined as the ability to do work. When you do work on an object, you make the object move. This is very important because if that object doesn't move, no work was done on it. So imagine a huge rock, and I walk up to it and I try to push that rock out of the way, but it's just too big and I can't do it. I try until my muscles are sore. I am so tired from pushing it. But if someone says, did you do work on that rock? As much as I would want to say yes, because as tired as I am, I would have to say no, because the rock did not move. So the object has to have that force. I was putting a force on the rock, but since it didn't move, no work occurred. All objects in motion possess kinetic energy. So if you remember back to 6th grade, you learned about kinetic and potential energy. So objects have kinetic energy because they had work done on them. Remember, work is when a force makes an object move in the direction of that force. Everything you do is connected to energy in one form or another. You can't help it just sitting there. Your body is changing one form of energy into another. So when you eat, your body's transformed the energy stored in the food into the energy to do work. So you, I hope, ate breakfast this morning, which was chemical energy, and then you walked to the car, and that energy from the food gave you the energy for your legs to move and for you to pick up your books and put on your coat, and that's mechanical energy. When we run or walk, we're burning the food energy in our bodies. That food energy is the chemical energy, and we break it down and turn that energy into a different kind of energy. So these runners right here are using that kinetic or mechanical energy. And when you hear mechanical, think moving, just like kinetic means in motion. Even when you think or you read or you write, you're doing work because all of those neurons in your brain are firing. When you move your hand and that pencil across the paper, you're making it move. So it's hard work. And as you know, sometimes it's really hard work. Cars, planes, light bulbs, boats, and machinery also transform energy into work. Now remember the movie Transformers. The cars would transform into those robots. So transforming means changing from one thing to another. So here, energy is transforming into work. So energy is always transforming from one form of energy to another. Work means moving something. You can move it by lifting it, or by warming it, or lighting something. All of these are a few of the various examples of work. But where does energy come from in the first place? Here are three different forms of energy. We have electricity. Electricity is the flow of electrons that we get from the power plants, which we'll talk about a little later. Biomass is the energy from plants. Remember that bio means life. So plants are living. So it's mass from living things. Geothermal is energy from the ground. Geo means earth and thermal means heat. So here we are up here on land, but if we dig down to where it's extremely hot, remember in 6th grade you learned about the different layers of the earth, to where this magma heats all this up, we can bring that heat up and use it to boil water to turn a turbine, and that we've talked about before, how the turbine turns the generator that creates the electricity. Here's a picture of a power plant. You're going to learn a lot more about power plants next year in 8th grade. But right now what I need you to know is that there are 3 types of fossil fuels that we use in these power plants to create this electricity. We have coal, oil, and natural gas. They are fossil fuels. Now, a few weeks ago, we learned about fossils and what they were. So when plants die and they get down in the layers of the earth and all that pressure over thousands and thousands and thousands of years, it can turn into coal, oil, and gas. And we burn those, changing that chemical stored energy to make electricity. One of the problems with the fossil fuels are they're non-renewable sources of energy. They are going to run out one day. Hydropower, on the other hand, is a renewable resource of energy. So we have hydro, which means water power, and ocean energy, where the force of gravity can use water to make electricity in hydroelectric power plants. You'll learn more about this next year, but for right now I need you to know that it is one of the forms of energy. We use the water to turn the turbine that turns the generator to create electricity. Last quarter you learned about nuclear energy, fusion and fission. Remember that fusion was a hydrogen and a hydrogen fusing together to make helium, giving off vast amounts of energy. And fission was where a uranium atom nucleus was split into two different elements and neutrons with lots of energy. Solar energy is from the sun. We can also call that radiant energy, and it can come in, for example, right here, and it heats the water and heats whatever it's under or on top of. Or we have solar panels that changes it into electricity, like your calculators. Another form of energy is wind energy. So if you look right here, there's a little generator in there. So as these blades turn, they turn the turbine that turns the generator that creates the electricity. So there are many forms of energy. Here are some of the renewable energy forms. We have biomass, solar, water, wind, and geothermal. In the next video, we'll learn different types of energy, potential kinetic, and how they transform from one form into another.